Hello everybody, today we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. This is problem number 3.45 and the question is to find the current I in the circuit. So this is the current I which is to be found out by us. So when we inspect this particular circuit, we come to understand that this consists of 4 number of loops. So we can draw the loops. This is loop number 1 with the current I1. This is loop number 2 with current I2, and then this is loop number 3 with current I3, and this is loop number 4 with current I4. So when you further inspect, we come to understand that there is a current source of 4 amperes which is connected between this loop 1 and the loop 2. It is a common current source between this loop 1 and 2. Therefore, we have a super mesh. So I draw the super mesh here. So we start with the super mesh and we are going to apply KVL for this loop. So if you check here, we have this 4 ohm and 2 ohm that corresponds to this I1 current. Therefore, we can write it as 6 I1. Then this 8 ohm and this 6 ohm resistance, these two are for the second loop. That's why we can write it as plus 14 I2. And this 6 ohm resistance is common to this third loop also, so that we can write it as minus 6 I3. 2 ohm resistance is common to this fourth loop also, so we can write it as minus 2 I4, that is equal to 0. So this can be divided by 2, so that we can write it as 3 I1 plus 7 I2 minus 3 I3 minus I4, that is equal to 0. So this is our first equation. So we are going to write KCL at this particular node. Let me mark it as node number 1. Actually, we cannot write the KCL at this node. Even though this 4 amperes current source is connected to this terminal as well as to this terminal, we are not going to write the KCL at this particular node. Why? Because this 4 amperes current source is common for only this loop 1 and loop 2. It is not common to this loop 4 and loop 3. If you try to write the nodal equation at this point, then all these loops are common, right? But we want to write the KCL for this node because this current source is common for only these two nodes. Okay. So at node 1, here the current I1 is flowing in this direction, this I2 is flowing in this direction, and the 4 amperes current source is flowing towards this junction or the node. Okay. So what are the incoming currents here? This I1 and this 4 ampere current source, they are all incoming currents, and the leaving current is this I2 current. So this makes our second equation. So now we move on to this loop 3. So for this loop 3, we are going to apply KVL, and in this we have the presence of this 3 ohm resistance, 6 ohm resistance, and the 1 ohm resistance. So we mark it as 6 plus 3 plus 1, that is equal to 10, 10 I3. And then this 6 ohm resistance is common for loop 2 and loop 3, so that we can write this as minus 6 I2. This 3 ohm resistance is common to fourth loop also, so we can mark it as minus 3 I4. That's all right. So that is equal to 0. So rearranging this, we can write it as minus 6 I2 plus 10 I3 minus 3 I4, that is equal to 0. So this is our third equation. Now we move on to the fourth equation. So for that we are applying KVL to loop 4. So in the loop 4 we have two resistances, 2 ohm and the 3 ohm. So the summation of these two is 5 I4. The I4 current is flowing through these resistors, and this 2 ohm is common for first loop also, so we can write it as minus 2 I1, and this 3 ohm resistance is common for third loop also, so that we can write it as minus 3 I3. And when you look into this 30 volts voltage source, the current I4 is flowing in this direction, so we encounter with this minus sign first, so it can be written as minus 30, so that is equal to 0. So this is our fourth equation. So we can rearrange it like minus 2I1 minus 3I3 plus 5I4, that is equal to 30. So this is our fourth equation. One more thing, we might have noticed that this I current is nothing but the I4 current we have taken. Okay. So whenever you want to solve, you should know that this I is equal to the I4 we have assumed. Okay, so now we are going to solve all these equations. So we got actually 4 equations and we have 4 loops and 4 unknowns are there, unknown variables, that is I1, I2, I3 and I4. But we can reduce this into 3 equations and 3 unknowns. How is it possible? You look at the second equation. From the second equation, we know that I2 is equal to I1 plus 4. So in all the other 3 equations, you can replace this I2 by I1 plus 4, so that you will be getting only 3 unknowns. Okay, so we'll do that. Now substitute second equation in first equation. So you write it as 3I1 plus 7 into, there you have this I2, isn't it? So in place of this I2, we write it as I1 plus 4, then minus 3I3 minus I4, that is equal to 0. This is actually our first equation. So this is 3I1 plus 7I1 plus 28 minus 3I3 minus I4, that is equal to 0. So you can write it as 10I1 minus 3I3 minus I4, that is equal to minus 28. So this is our modified form of first equation. Now again you substitute the second equation in third equation. So what is our third equation? It is minus 6I2 plus 10I3 minus 3I4, that is equal to 0. Actually this is our third equation. In this I am going to substitute second equation, right? So this I2 is to be replaced, isn't it? So it is minus 6 multiplied by this I1 plus 4, then plus 10I3 minus 3I4, that is equal to 0. So it is minus 6I1 minus 24 plus 10I3 minus 3I4, that is equal to 0. So I can rewrite it as minus 6I1 plus 10I3 minus 3I4, that is equal to 24. So the modified form of the third equation. So now we get all the 3 equations together with the 3 unknowns. Okay, so we have the 3 equations with the 3 unknowns. So now we are going to solve this. So how to solve this? I'm going to use Grammar's rule. I'm going to write all these 3 equations in matrix form. So writing the coefficients of this I1, I3 and I4. So this is minus 6, 10 and then minus 3 in the second equation. From the third equation it is minus 2, minus 3 and plus 5. So here we can write the variables I1, I3 and then I4, which are unknowns, right? So here we have the voltages. So minus 28, this is 24 and then this is 30. So from that I can write this delta values, right? So delta is equal to this determinant of this coefficients. So it is 10 minus 3 minus 1 minus 6, 10 minus 3 minus 2 minus 3 plus 5. But in order to solve this easily, I can extend this determinant like this. So I'll be repeating the first 2 rows, so that it is 10 minus 3 minus 1 minus 6, 10 and then minus 3. So we can draw the line like this, 10, 10, 5. So on this right hand side it is plus value multiplied by plus. Similarly here also these 3 values must be multiplied and multiplied by plus. Here these 3 then plus. Okay, so now we'll do that. So 10 into 10 into 5, it is 500. Already plus sign, plus into plus plus, so it is plus 500. Then here minus 6 into minus 3 into minus 1, so it is minus 18. Minus into plus, it is minus again. So here it is changed to minus, so minus 18. Similarly, you go for the next one. It is minus 2, minus 3, minus 3. So it is minus 18. So minus into this plus, we get this as minus. So it is minus 18. Then you can add all these 3 values, so that we'll get it as 464. When you go for the other side, here we draw these 3 lines again, but we put minus here. This is your second line. We have to multiply all these values. Then this is our third, multiply, and then the resultant should be multiplied with minus value. Okay, so we'll do that. So minus 2, 10 into minus 1. So minus minus plus 20. Already the minus sign is there. So we'll be getting this as minus 20. Then to the next, it is 10 into 3 into 3. So it is 90. Already this minus minus becomes plus here, but minus sign is there. So minus into plus, it is minus again. So we get this as minus 90. Then the last one, it is 6 into 3 into 5. So again it is minus 90, because here you have 6 into 3, 18, that is plus 18 multiplied by 5, it is 90. So here already you have the minus sign, so it becomes minus 90. Now you have to add all these three values so that we get it as minus 200. Then what you need to do is, here you have to add this minus 200 with this plus 464 so that we get it as 264. So what's the value of delta? So delta value is equal to 264. So what is the value of delta? Delta is equal to 264. Now we are going to find out this I4 only, right? Because I4 alone is asked. I4 is the one which is asked as I in the circuit, right? So in order to find out this I4, I am going for this del 4. So how to write this del 4? So for that, it is, again you draw this determinant line. So you draw the determinant line, the lengthy one, because we need to write 5 rows with 3 columns. So this value corresponds to the last one, right? This I4 corresponds to this last column, right? So these values should be replaced by this voltage matrix values, isn't it? So we'll do that. It is 10, it is 10, minus 3 and minus 28. Then we have minus 6, the 10, and this minus 3 should be replaced by 24. Then here it is minus 2, then minus 3, the 5 should be replaced by this 30. Then we repeat 10, minus 3, minus 28. Repeating the second row also, minus 6, 10, and then 24. Now you draw lines for which we are going to do the multiplication. So it is 10, 10, 30 with the positive value to be multiplied. And then this minus 6, minus 3, minus 28, minus 2, minus 3, 24. Okay, on the side, starting from this, minus 28, 10, and then minus 2. Then 24, minus 3, 10. Then 30, minus 3, minus 6. So now you write the values for this. 10 into 10 into 30. So it is 3000 multiplied by plus. So it is plus 3000. Then minus 6, minus 3, then minus 28. So that is equal to 504. But minus minus minus, so it is minus 504. Then here minus minus, so you get plus sign only. Okay, 2 into 3 into 24, that gives you plus 144. So when you add these three values, you get it as 2640. Similarly, you do it on this side. It is minus 28 multiplied by 10 multiplied by minus 2. So it is plus value, but you need to actually multiply by minus. Okay, so it is minus 560. Then here 24 minus 3, 10. So that is equal to 720. But here it is minus 720, isn't it? Minus 720, but you need to multiply it by again minus, so it becomes plus 720. So here you get the positive value initially, that is 30 multiplied by minus 3 multiplied by minus 6. So you will get it as plus 540, but you need to multiply it by minus sign, so minus 540. So when you add all these three values, you get it as minus 380. So you have to sum up here, minus 380 plus 2640. So you get the del 4 value as 2260. Already we got this del value. Del value is 264. So what is our I4? I4 is del 4 divided by del. It is nothing but 2 1260 divided by 264. That is equal to 8.56 amperes. And we know already that this I4 is nothing but the I current, isn't it? So, and the answer is 8.56. So, this answer is equal to 8.56 amperes. Okay, hope you have understood. Thank you.